or good afternoon, everyone, and thank you for joining us. Yeah, as mentioned, today we will basically explore the role of AI and machine learning in fraud detection and hopefully its potential to transform fraud prevention. Especially the one that we will focus today will be around false alarm. But before we start, I'd like to ask a question, if I may, and please answer with yes if that applies to you or any comments that you may have. And it's the following: have you ever had your credit card unexpectedly, decline after making a purchase, or or a booking or reservation? Feel free to answer with yes if that has happened. And I have another question for those that are involved in fraud prevention systems, like fraud analysts. Do you also face a high false positive rates, and is that an issue in your organizations? I'll pause in a second. If you have access to chat, feel free to comment whether that's the case and or any observation you may have. Yeah, I mean, feel free to also to respond directly to me if you don't want to put it in the public. I don't know if it's possible even to put it publicly, but feel free. Also, okay, so I had that the chat is displayed. So then put it in the Q&A. Okay, I see several responses, and that's also the issue. And in principle, what I want to say is that if you're facing these type of problem, you are not alone. And we're going to see during the presentation that indeed 90% of the many of the current systems, 90% of the alerts that the system give on transaction, for example, has they are false positive, and those numbers are really indicating that really we need to improve these systems. We're going to see that how or to what extent AI and machine learning can pave the way for more efficient approach. So let's continue. And one thing that I wanted to start with is actually fraud is a big problem on its own. So especially as we progress further into the digital age, or to put it simply, the more we shop online, the more we create opportunities, to create, or like giving more opportunity to fraudster for their fraudulent activities. And I just wanted to highlight the fact that just to understand how big that issue is, there is an estimate that 6.4%, like the cost of the fraud globally is 6.4% of GDP. And to put that into perspective, that's around a bit more than $5 trillion US, which if you compare that with the GDP of countries, it's more than GDP of Germany, so the richest country in Europe. So the fraud, the cost of fraud is higher than what Germany makes in a year. So and that's increasing. But the surprising fact, perhaps for many, but not for those that are involved in fraud detection, is the following: the money that we spend trying to stop fraud, on average, are 3 times more than the fraud itself. So what it means is that the challenges that many businesses face when we are talking to isn't primarily about the fraud itself, but rather fraud prevention system that cost more than fraud itself. And as again, I mentioned that it's 3 times, but on average, but there are areas that it could be up to 10%, up to 10 times. These fraud detection systems costlier than the fraud itself. So what we've done here, it turns out that in order to solve one problem, we have created even a bigger problem. So why that happens, there are a variety of things that contribute to that, but one major one is a high rate of false positives, like false alarm, the transaction that should have been passed through but blocked by or rejected by fraud monitoring systems, and that in many cases they exceed, as mentioned earlier, 90% of the cases. So just a simplest case that how these rule-based systems work. First of all, the majority of the cases are actually rule-based systems still, and they are the reason that we like these systems is because they're really fast and transparent. So if a transaction gets rejected, we know which rule has been applied. And how these work is as the following. So for example, in case of credit card payments, if there is a payment going through, there are certain questions that will be asked by the system. Is the card physically present or not? And where the transaction take place? And how far the location of the transaction's been. So depending on the questions, whether, for example, the location of the transaction in case of card present was kilometers apart, but happened in a short period of time, then that's an indicator of fraud. So, those type of rules is implemented in a simple way, if you want to put it, and then the system checks it, and then depending on whether the rule applies or not, they flag it as alarm or not. The one point with these systems is that they are not using a lot of data points that are available. Many of these systems that already exist using only limited number of data points like geography, amount, rate of transaction, frequency, and things like this. And as a result, what happens is that it leads to a less accurate model. And in order to compensate that lower accuracy, they tend to be a lot more conservative. So what it means, being more conservative, it means that they're rejecting a lot of transactions that otherwise should have been just when should have gone through, right? And on the other hand, there is another issue is that they are less flexible. So when a new type of fraud emerges, then fraud analyst needs to go through the type of frauds that's not been detected, and see if there are certain patterns in those type of frauds. That, can we create a certain rules, and then these rules needs to go through the analysis, review, and validation, and then implementation. So that's a lengthy process, and with that approach, we'll always staying sort of behind fraudster. So in previous slide, I've mentioned a few challenges that we have faced, but in general, there are a couple of challenges that I've just pointed out. A few of them, in real cases, might be even a need to expand this, but perhaps the important ones that at least when we are talking to our customer, we see that they're highlighting. Number one, high false positive, as mentioned earlier. The other one is evolving fraud patterns, that any system that we are going to implement in this environment needs to be agile enough so that it can stay ahead of fraudster. And then at any place, it's not really only a transaction. Any place when we introduce security, we just need to be conscious about the impact and implementation that impact that it will have on user experience. And indeed, a survey has shown that if one for no reason a transaction for a credit card it's been rejected for no reason, when users use that credit card, they responded that if that happens only one they will not use that credit card again. 25% of the respondents. So that really, highlights that, if you're going to, basically false positives lead to you lose like close to 25% of the clients. And being able to use a variety of different data sets, that's another point. As mentioned in previous slide, many of these rule-based engines use limited data points. And an actual study by MIT has shown that if you're using data points like customer behavior, like how the customer use for certain credit cards, what is the spending pattern. If we use that, we can simply, by just incorporating that information, reduce false positive by 25%. And this system really needs to run in real-time processing. And one of the reasons I mentioned why we like this rule-based engine, because they are very fast. If you have the best system ever in the world, but it takes half an hour to respond, that's not going to be useful for transaction monitoring systems. Regulation and compliance is another thing that we need to keep in mind. New technologies, cryptocurrency, mobile payments, all these new technology coming in. So whatever solution that we use, we need to be able to sort of incorporate those. And integration with other systems, especially legacy systems, is another point that we need to consider. So the system needs to be flexible in that sense. The other point, basically the last point that I wanted to point out, is that at the end of the day, considering all these points, our solution needs to be accurate enough to detect fraud. So that really is challenging, a striking balance between all these requirements and the boundary conditions that we are in. One thing that I wanted to highlight before we continue is the following. In this presentation and the example that I'm going to use, I will be focusing on transactional fraud, but many of the points that we make today can be applicable also to other type of fraud like AML or application account opening fraud, and also in different industries like telco and some of the frauds they're happening there. Also, the points that we make today can be applicable in those areas as well. So, but before we start, there's one point that I'd like to mention, because when any system that you want to introduce, the question always is that what is the effectiveness? What should we expect from going and implement that? And in order to have just a perspective that applying solutions like using machine learning in different industries, what they have achieved. Here is one example from AT&T that they have started from only rule-based engine and augmented their system by introducing machine learning-based approach. And in the span of 3 years, they have been able to reduce fraud by 8% by incorporating machine learning-based approach in their solution against fraud. So the case study that we will be working at today is based on a customer of us. They're a large financial institution processing a huge volume of transactions. And like many of our customers, one of the issues that they had was the high volume of false positives in their rule-based engine. So they were looking for approaches that to enhance and basically augment their solution. So what they wanted to achieve that is twofold, mainly reducing fraud while also at the same time reducing false positives. As again mentioned, they are a bit difficult to achieve at the same time. The reason for this is that if you want to recognize more fraud, meaning that you need to be more conservative, and being more conservative means that introducing more false positives. But they wanted to achieve that by utilizing machine learning, and we're going to see that how that worked out. So what we see in this slide is so I'm going to go through different steps of how different machine learning techniques can be added or enhancing the existing rule-based engines, because I don't think that we will be able anytime soon to replace these rule-based engines due to many requirements, specifically regulations they're going to be staying there. But the approach here is that to enhance them by machine learning techniques. So how this rule-based engine works, as mentioned earlier, if the transaction comes through, they will score it, whether they flag it as fraud, and it goes through a review by a fraud analyst, or it just goes through. The point here is that because they're not accurate, many of the some of the transactions that go through non-fraud is actually fraud, and the bigger problem here is that actually many of the transactions that has been flagged as fraud are legitimate. Just to have an idea of what the size of these frauds are, at least in the US, the size of the fraud, undetected fraud for credit cards is around $9 billion US, and the cost of false positive, like this screen that should have been through this path, but identified as fraud, it's more than 100 billion US dollar. So easily we can see that here, at least in these cases, in case of credit card payments in the US, the cost of false positive is actually 10 times of the fraud. So what was the first step that these specific customers applied? One thing that these fraud analysts are doing is they are creating labeled data for machine learning, actually. So they are labeling all the flagged transactions, whether that was a false positive or it was actual fraud. So, this is really a valuable thing, because we can use now this data to build a supervised model, which basically can imitate sort of what a fraud analyst would do. And if the model thinks that it's really low likelihood that this transaction is fraud, it can reroute that transaction to that non-fraud cases, which is really can reduce a large amount of false positive. And we will see later on for this specific customer what was that number. The other thing that we can do, because some of the frauds that go undetected first will be reported later on, so those can be used again for another supervised machine learning. They can sit here, and again, if there is a high likelihood of that transaction is fraud based on that reported cases in the past, so we can reroute that back here as well. And there are always cases that always go unidentified, whether that's a new trend in fraud or things like this. In those scenarios, what we could use easily is anomaly detection. So anomaly detection looks into typical behavior of clients and credit card users. For example, if it identifies that this is a sort of anomaly, is not in line with the past sort of behavior, then can raise alarm. So here we don't need labeled data, so we can just use the historical transactions, and it discovers like typical behavior, and based on that can reject or let it go. So again, with this we can reroute back some of the transactions that been false positive, and these can add another defense against those cases here. So what we have used to implement this is, it was H2AI Cloud. So it's a platform that enables us to implement, solutions similar to that we have discussed. It allows us to build really not only to build but also deploy and understand these models more quickly, easily, and also creating more accurate model through automation. So that I'm going to show shortly how that looks like. So as a result, that leads to enterprise being able to implement, these AI initiatives or like machine learning-based solution, and reducing, risk of failure by managing the entire process, and automation, which, failure of the project is sort of prevalent in our industry, as we might have heard. So I'm going to go through this 3 steps quickly, how we can use H2O platform, specifically for model building. We are going to use driverless AI. This is an AI engine. We can see that how we can use, and by starting from the historical data set to build a model, we're going to deploy that. And I'm going at the end use an application that sort of wraps around the model that we have created and deployed, and then we can get additional insights and some additional analysis that we might want to apply to that model. So with that, I'm switching to the driverless AI. So this is an AutoML tool to create a variety of different models. One that we can see is a fraud detection, but it could be like, forecasting, time series, or what other techniques. The idea is that we are going to start with a historical data set. This could be any of these type of data set that we have mentioned earlier, whether that's the flagged version from a rule-based engine, or the one that is not flagged for the other models on the top route. So whatever that we want to build, we just need to load the data set here, and the specific data set that I have here is like this one. We have certain, that's a demo data set that is not as rich as what you would perhaps have access to in the real case. But what we have at least here is the customer data, like age, gender, the location, the merchant information for that specific transaction, location of the merchant, category, amount, and whether that was a fraud or not, which basically most of the cases is not really fraud. And then some additional information, like what was the last day transaction count, last 7 days, last 30 days for that specific customer, and specific customer with that merchant. So a combination of those. And what I'm going to do is basically use that data set to build a model. And building model using driverless AI is quite straightforward. I need to just select the data, select the predict. Because many steps are automated, I just need to specify a few things. One was what we did, data set. The other thing is that what we want to predict, in this case, fraud. So I'm going to specify that. I have also a test data set that I want to get a report at the end of the experimentation. So I want to see what my model performs on this test data set. And that actually is what I really need to do before I start the experiment. So all the rest, like how the feature engineering should be done, what models should be used, how should be fine-tuned, how those models should be tuned, and all these aspects will be taken care by driverless AI. So by clicking launch experiments, it will go and investigate all these points that I mentioned, automatically builds the model and makes it ready for deployment or understanding those models. However, given that it's automated, but still, if you have expert data scientists that they know how to use the platform, or like they're familiar with advanced machine learning techniques, they will be able to go into expert settings and change any settings, have a full control of entire process. But we are not going to do through that today. One point that I wanted to mention is that, again, because there's automated, there's a lot of things that this platform can do to come to a best model. But sometimes due to regulations, especially in financial industries, we are moving in a regulated industry. What we can do here is that, given a hint to driverless AI, that build a compliant model. So what in principle that makes it the voice to use complex algorithms, or a lot of feature engineering that might make it a bit difficult to interpret. So we can use these sort of hints and sort of guide driverless AI to build models that is also compliant in our industry. But I'm going to close that for now. And again, as mentioned, all things that we needed to do is just that and click launch experiment. So I'm not going to do that right now, because I've already created an experiment that we can go and have a look. So if I click the launch experiment at the end, when the experimentation finishes, we're going to see that view. So that's a finished experiment, and we see here that there are a variety of different models have been tried out. Each point really, shows the different models that's been created out, and then has been tried out and evaluated. And there's a few things that I like to show here. First of all, obviously when an experiment finishes, we want to see how good this model is. So we can look at some of the metrics and the ones that we prefer. And then in summary, there is one thing that I like to also highlight, and it is, as mentioned earlier, one thing that's very important when we are creating these models is the latency. And there is a specific artifacts that when you build a model can use and deploy either externally in different if in your monitoring systems if you have, or in MLOps here inside the platform. Whatever environment we want to use, it's flexible. We can download or put it in a variety of environment. But what is important, I wanted to mention, is the latency. As we can see, it's 1.6 millisecond for this specific model. And we see here a Python variant of that. So majority of tools out there are using Python. And if we want to use Python, we will see easily here that how the latency is compared to this, like 3 times slower, 300 times actually slower than, or some number closer, maybe 250, 260 times slower than actual Mojo. So you can see that how faster these Mojo scoring pipelines are when we are going to deploy that. And that's one of the reasons one of these financial institutions is actually working with us, because what the feedback that we get is that not only that we can create now a very accurate model, but also is really complies with the latency requirements that we have when we are going to deploy these models live. One thing that I wanted to highlight before we move on is that now that we have created this model, we can now go and look at various insights from this model. Like there are a variety of plots that we can go, but perhaps we don't have the time today. But what I wanted to mention is the following: we are not just building a model, but we can go and investigate local sensitivity analysis, disparate impact analysis. Basically, just shows us that how if these models do show a certain biases to certain groups, or Shapley values that we can see. For every predictions that we do, we can get also the indicators why this model thinks that a certain transaction is should be dropped or not. So I'm going to show you some of this plots later on in the application. So but what is important is a variety of insights that we can extract from the model, and also present those and expose those to various applications that the end user, like fraud analysts, can look at those insights when they do run their analysis. I'm going back to the experiment. There's one thing that I'd like to also highlight is because a lot of steps has happened under the hood, so and automatically. But especially in regulated industries, again, there's a requirement that we exactly need to know what has happened, what models has been deployed. There's one thing that we have here is we call it AutoDoc, so it's automatic documentation. So if I click this, I will get a document, maybe something like that I've already loaded here, like this one, that it's really puts details on how exactly this experimentation has been gone through, from data itself, the data sampling, if it has been done, validation strategies, and a lot of details here, as you can see, is listed in these documents. Like in this case, it's 54 pages in principle documentation that is created, and these sort of can be shared with or can be used in review process, because in many financial institutions you have this review process that someone needs to really approve the usage of this model, and this documentation can be used. So that's sort of how we can build a model. And the next thing obviously is deployment. So I can click here and go through the deployment process. I will skip that for now for today. But after deployment, we'll have monitoring also in place that monitors whether that model runs correctly. The totals, the transactions has been going through the model, latency of this model so far, what was the average latency, and all this monitoring. Also, data drift if data is changing, so we can have all these aspects here being monitored. One thing also I want to quickly highlight is, okay, we have built the model, now deployed it. One thing that I can do in that platform is also create an application now that can use this model, and this one is one of those applications. I've called it transactional fraud detection. What it does is, as the transaction comes through, it goes through two of these models that I've mentioned earlier. One gives me a fraud score, the other one is anomaly score, and based on that, we can decide or specify a threshold from where we need to drop this transaction or reject this transaction. And as you can see, like in this case, that's the fraud score, that's the anomaly score, and as mentioned earlier, we are not only getting these fraud scores here, but we can also see things like what was the payment amount, what was the for this specific case. I mean, depending on which case we are looking at, the reasons might be different. But it also gives us reason. For example, in this case, the number is high because the payment amount was like that, and the merchant number was this. So it sort of also gives us a insight why the model thinks that these numbers are high. And one other thing that I like to highlight here is the further diagnosis that we can run on these models. And in addition to the fact that the machine learning is able to capture a lot of frauds better, and also that reducing false positive, we have other tools that we can utilize to further optimize even these models that we have created. One thing that I want to highlight is the following: when we have when we build a machine learning model, they're not just saying that, okay, this is fraud or not fraud. They give us a likelihood of being fraud. So from 0 to 1. And then we need to define a criteria like this one here. So I can say that okay, criteria could be like 0.5, and anything above 0.5, I'm going to consider fraud. Anything below 0.5, I'm going to consider legitimate transactions. And based on that, we can create a confusion matrix. What is confusion matrix? It basically says from the fraud cases that we have and from legitimate cases that we have, how much of these models is being captured correctly. So in this case, we have a lot of legitimate cases. So in this row here, we have all the legitimate cases, and that's and if we have a legitimate cases and the model correctly identified those as such, then we call it true negative. If there is fraud cases and the model has been correctly identified, that we're going to call that, it's called true positive. But models could make a mistake as well, like a transaction could be fraud, and model could fail to detect that. It's called false negative. So model says that it's legitimate, but it's not. And there are cases that it's legitimate, but model might think that it's false positive. As mentioned earlier, the rule-based engine problems that they have a lot of false positive because again, they are not accurate, they're very conservative, and the cases more or less we can simulate that by going very conservative to the left here. So if you put criteria we are very strict on that. So as you can see, as I move to the left, I'm creating a lot of more false positive. So that's actually a tool now that I can use and optimize or like balance between these false positive or false negative. And one way is to look at this from the false positives and false negative from the number point of view, like how many cases I'm going to correctly identify as such and how much not. But one way also is to translate those in dollar terms or euro terms, right? So I can assign, okay, if I'm going to, if my model has that amount of true positive, what is the benefit for me? How much I'm going to save? Or if I'm going to have false positive, what is the cost associated to that? Like, the transaction that is not going to happen because that's supposed to be a legitimate transaction. Now I'm going to miss that transaction. And also the future transaction because of customer churn might imply, so I can reflect that in the cost of false positive. And then there are other cases, again, here, the false negative. It could be the amount of fraud that's going to happen. So I can associate that cost. And based on that, now instead of numbers, I can optimize based on the cost, the benefits and savings that I'm going to do. And actually by moving this from left to right, I can create a plot like this, and I can look at where this plot becomes maximized, either by visually, or also that could be automated, like uploading a historical data set that I know where the fraud has happened. And I can choose the score either based on cost reduction. So I can create this, select this one and say, okay, optimize this for me. And I can see in this plot how that reflects itself. And here is another plot that sort of representing these in this graph. So this is fraud amount for applying a model, and then here we're applying a model that hopefully we recover a lot of false positives so that we can have a saving. Here, the red one is the ones, false negative ones, like the ones that the model fails to detect, and the orange one is the cost associated to false positive. So as you can see, as we go to the left, we become conservative, and we reduce false negative, like detecting more fraud, but also increasing the false positive, which increase the cost. And as mentioned earlier, these sort of stuff, all the main issue of this rule-based engine, so that we can optimize and sort of get these two being optimized and maximize the amount of stuff. So I just wanted to mention that, okay, here we have additional tool because these models gives us a likelihood of the fraud. So we can utilize that point to optimize further and get to the point that makes sense for our business. Sometimes we have to do based on these numbers because of regulations, but if we have that space to use cost-based assessment, that's really good tool that some of our customers are using to optimize the threshold and optimize the way that the balance between false positive and false negative. So yeah, that's all for the demonstration I wanted to have today. So basically, now the question is, when we implement that, what could we expect? In this specific case, implementing these models and in that customer's environment, they have reported that they have been able to reduce false positive by 64% and double the number of true positive that they've had comparing to their existing system. So, and also in conclusion, I'd like to emphasize that there are diverse industries that trust and depend on HDI cloud. That was one example, but there are a variety of different models that we can create, and similar to the ones that I discussed today, again, to enhance efficiency and mitigate the risk. This is the one that has been discussed today. So that was all I wanted to cover for today. And as we wrap up today's session, I'd like to thank you for joining us. And if any of topics that we discussed today resonated with you, or if there's anything else that in your mind you wanted to share with us, don't hesitate to reach out. And yeah, we are delighted to have further detailed conversation if that fits you. And also, if for those that are interested, feel free to schedule a deep dive demo under this link if you'd be interested to see more of how these different steps that we discussed today really works in practice. And I think we still have enough time for answering a couple of questions if you have. Let me see if there are any questions. Feel free if you have any questions. I guess we have still 2-3 minutes left that we can. So we have a question saying that, does the optimization pipeline carry out feature engineering too? So what kind of features we created? Also, what about feature selection? Yes, that's a good question indeed. These scoring pipeline, and that's why we don't call it model. It's called scoring pipeline because it incorporates feature engineering. What feature engineering is part of that? There are really big list of feature engineering that Jarvis AI can handle it, depending on which ones improves the model. So it's a dynamic process. So what it means is they will try a variety of that, and that's experimentation that we have seen. More than 800 different feature has been tried out, and at the end only, if I remember correctly, it was around 100 cases that has been selected. So, and that features will be part of that pipeline. See, there's another question. The question is that given that fraud cases are a smaller percentage of the overall transaction number, does Jarvis account for that? Do we need, or do we need to manually do the sampling, like over sampling? I mean, to be honest, that's a really good question, because that's one of the reasons why we want to use AutoML, because all these questions: do I need to do oversampling, undersampling? How I'm dealing with such an imbalanced data set. So Jarvis AI runs a process, and depending on really what we also set the criteria that what is the level of aggressiveness that it should address it. But in principle, Jarvis AI automatically deals with imbalanced data set, and then what type of sampling should be applied, how the modeling technique should be used, because we are using imbalanced like GBM and imbalanced XGBoost as well, and with various sampling approaches. And in principle, you can also Jarvis AI will create also a bagging approach that basically gets it creates multiple models and gets the averaging, and really variety of different techniques will be applied in order to take that into account, that you're dealing with an imbalanced data set. So we need to take that into account. Having said that, we can also influence how Jarvis AI basically addresses that aspect. So if we prefer different ways, and that's in a standard way that we want to use, we can impose that, do the imbalance after the criteria is this, or do use that of oversampling, undersampling with that criteria. And one question is, does the HDA account has a free trials? Feel free to reach out to us under this also link. We will organize, we'll discuss what was the best approach for the trial. And one question is that what ML algorithms used in H2AI Cloud, like XGBoost? So there are a variety of different ways. XGBoost, like GBM, random forest, and there are really many different algorithms. And also, one thing that I like to mention, you can also add in your own algorithm if you prefer so, if you have a developed certain algorithm you want to use that, you can incorporate that as well, including feature engineering that you prefer or scoring type that you prefer. We call it custom recipe. You can incorporate those as well. And at the end, that's a genetic algorithm is running behind the scene, so it optimizes which of these algorithms could be useful or could improve the model, and which feature engineering is useful, and all these will be selected during the process. Okay, I guess we have one last question that we can incorporate. I think that we have 1 minute. And let me see. There's another question. Is it correct that the train and test process needs to be data needs to be pre-processed or normalized and things like this? No, you don't have to. One thing that I didn't show you, you can do also automatic visualization if you like, and Java's AI basically presents you all the if there's skew in the data set, or there's certain gaps, or outliers or anything like this. It will present you, but you don't have to normalize those stuff. Java's AI, as part of feature engineering, will be taking care of it. And whether certain approaches is useful or not, that will be seen objectively as part of that process. So that's all. I guess we're 1 minute even beyond the what's scheduled for today. And there's a couple of questions that I couldn't go through them and said today, but we will make sure that we will reach out to you through emails if I believe we have information. Afifa, we need to collect all these questions, I guess, reaching to them back after the call. All right, with that, I guess I'm giving back to you the Afifa.
Yes. So thank you everyone for participating today. As Asghar mentioned, we have your contact details. So all the questions that were left unanswered will be answered, and the recording will be also sent to you. So with that, thank you for joining us, and we're looking forward to joining you on our next webinar. Thank you so much.